Hi friends, greetings and happy Independence Day. On this occasion, I also wanted to do some kind of analysis with respect to the speeches that are delivered on the occasion of Independence Day. Our Prime Minister, Mr. Narendra Modi, delivers the speech. So we thought of why not do topic modeling on the speech that is being delivered. So here we go. We want to discover the key themes and insights from the speech that was delivered by our Prime Minister. But the interesting point here is we wanted to take all the previous speeches as well. So from the year 2014 till this year 2023, we have gathered all the text speech format and text format of the speech that is delivered by our beloved Prime Minister, Mr. Narendra Modi. Now, what exactly we are going to do is try and perform topic modeling. This basically is going to help us to derive the potential insights from all the speeches that were delivered till now. Now, if I analyze these speeches, we can identify the core messages, what are those priorities, and what are the various kind of sentiments that are being conveyed to the citizens of this nation. This also tries to express, or we can also understand and identify what is the vision of the government of this country. Now, you need to understand what exactly is topic modeling. Now, thanks to LLM models like ChatGPT, of course, a lot of focus has been invested towards these concepts of topic modeling, NLP. So if I have to quickly explain what exactly is topic modeling here, then you can see that it's basically one of the techniques in natural language processing to uncover the hidden information from the large text data. It's a statistical model basically. It tries to discover the abstract topics. So what happens is if I have a document or corpus, for example, then you'll have a lot of tokens within that particular corpus. If you want to analyze, let's say tens of thousands of tokens, then it is going to take a lot of processing time. Now, topic modeling can also allow us to ensure that the entire corpus is divided into specified number of topics, say for example, 3 topics or 5 topics. So your entire corpus is now segmented into 3 or 4 or 5, whatever the number of topics that we are choosing. This way, the number of threads that are required to process is significantly coming down. Rather than analyzing the corpus via documents, we are analyzing entire corpus now via topics. It will allow us to basically, as I said, interpret the large text. It simplifies the entire process of analyzing the textual data. It allows us to identify the most important themes from the entire corpus. It also allows us to cluster the documents, group them, right? And ultimately, it allows us to identify some hidden patterns in the text data with respect to the context as well. The sentiments have to be identified from the text data, right? So it allows us to generate those insights. Now, if I talk about topic modeling, there are many topics or many methods which allows us to do topic modeling. Several algorithms are available. For example, NMF, which stands for non-negative matrix factorization, LSA or LSI, latent semantic analysis or latent semantic indexing. Then we also have TF-IDF, which is kind of a very popular technique in analyzing our text data. And we also have LDA, Latent Dirichlet Allocation. Now, this is what we are going to talk about today, a generative probabilistic model. Now, what LDA assumes is that your entire corpus, which is of course again made out of documents, is actually part of few topics. Now, those topics is something that we will have to try and identify. When I say topic, from a contextual perspective, it basically talks about a specific agenda. So we are trying to understand that agenda from the entire corpus. Now, we are trying to ensure that we first prepare the data, any text data or any data for that matter. Without pre-processing, we cannot analyze it. So we are trying to analyze the text data, and as the first step, we have to clean it. Now, as part of the cleaning, of course, tokenization will be one of the important aspects that we'll have to look into. We'll also have to check the typos, punctuation marks, special symbols, numbers, extra white spaces, unwanted text, which is probably very frequently used. For example, our Prime Minister, Mr. Narendra Modi, uses brothers and sisters, the specific term a lot. So we don't want this kind of frequently used words as well. So you might want to create a custom dictionary to ensure that you remove these words. Then another very important step is identifying different forms of English words. We use a concept of stemming to identify the stem words. We can also try and use lemmatization, which also gives us more appropriate form of words rather than simply applying stemming. We can also use the predefined set of words, which are called as stop words, to clean all the regularly used joining or you can say stop words, which are also used as filler words. We can clean them off. So there are various other things that we can perform depending on text data. Now, this is our Narendra Modi's speech, Independence Day speech. So we did, of course, some part of cleaning, and we did tokenization. We also have identified the stop words and filtered that out. And finally, we also have done lemmatization. Now, once the data pre-processing is completed, we went ahead to perform LDA. Now, when we talk about LDA, this is a very interesting point that I wanted to mention. See, as part of the textual analytics, we know what does corpus means, we know what does documents means, we know what does words or tokens means. Now, what LDA is doing is it's trying to help us to do reverse engineering in order to understand the topics, the context behind these tokens, which are combined together in documents and of course in corpus. So in LDA, we assume that every word is part of a topic. Every document, in fact, is part of a topic. And each document can also be part of mixture of topics, right? And each topic is viewed as a mixture of words also. Now, of course, unless until the words come together, the context is not created. Now, in LDA, we use something called as Dirichlet distribution. And this is basically the mathematical concept behind the LDA algorithm. It's not a normal distribution, of course. It's kind of a different distribution altogether that is followed. You might want to experiment and explore more about the Dirichlet distribution. Now, in LDA, the very simple steps that we perform is we first define the number of topics for a document, for example. We know that we are assuming that a document can contain mixture of topics, right? So we come up with set of topics so that the entire document can also be broken down into those topics. It's done based on Dirichlet distribution. Then for each word that is token in the document, we assign one of the topic that we have identified, and thereby we are segregating all the tokens among these topics. So this is basically the probability distribution that we are doing for the tokens, and that probability distribution is Dirichlet distribution. So finally, the outcome that we get is topics which basically are identified with certain tokens. So this is basically high-level steps for implementing LDA. Now, as part of this study, I've also used something called as PiNDA Viz package. Now, this is a very interesting package. It allows us to interactively identify or interpret the topics that we have extracted. As you can see, it gives you a nice web-based application for visually interpreting the results. It allows us to see the topics in scatter diagram. You can see this part where the left side, right, you basically have the scatter diagram. So as part of this, we've identified 3 topics. So you see 3 circles. These are the scatter diagram that we are trying to identify. This part is your scatter diagram where it shows the number of topics. Then here on the right side, you would see bar graph, horizontal bars, which represent the overall frequency in blue color, and the red color specifies the frequency of those documents, so the topics within that particular topic. The circles, the topics which are placed close to each other, that means there is more similarity within those 2 topics. The size basically talks about the proportion of the keywords that are coming into that particular tokens. For example, here, top 30 most relevant terms are shown, and we are seeing 46.2% of the tokens are there. So from overall the entire tokens that are identified, you are saying 46.2% of the topics are there in the tokens are there in the first topic. Now let us see the working model. So I'll jump into identifying this code. I'm using Jupyter Notebook here. So you can see the packages that we are using are Jensen, NLTK, and you can also see this particular package PiNDA visualization. I'm also using lematizer and stop words. And for generating LDA, we are using LDA model from GenSignet. The text files are located in a specific directory, and each of this text file contains the Narendra Modi's speech starting from the year 2014 till 2023. So these are individual files where we have stored the text. Now, using this custom function, we are reading each file, we are accessing each file and creating a single variable file data, which accumulates all these different years' speeches. So everything is now stored into a single variable. Then we are trying to do pre-processing on the text data. We are using WordNet lematizer, and I'm defining a function called stem here, which does the lemmatization. I'll write a custom function here. I've written a custom function, which is basically to do the processing. And if you observe here, I'm considering the words which are at least the length of 3 or more. This way, I'm removing all those filler words which are probably not relevant or they may not give you appropriate information in the context of the speech that we are discussing. So I want to check the number of letters in which your token is written. You might want to change this to 4 letters as well. The length is 4 means you will have 4 letter words. You can customize it. You can define whatever you want to pass on. Then I'm writing another custom function which basically analyzes the entire topics from the text. So LDA model function is being used, and then we are also bringing in corpus and text. Here we are trying to create a dictionary, right? Main topic, percentage, keywords, and text snippets. So these are all the dictionaries that are getting created in this custom function. So we do pre-processing, and that pre-processing next moves to gathering all these important dictionaries that we want to use for doing topic one. Here we are actually using those custom functions that we have defined here, the pre-process custom function, which in turn uses the stem function that we have defined here. And then we are calling this dictionary custom function, which basically allows us to bring in the pre-processing task on the data. Now we are doing this on year-wise as well. So I'm choosing 2023 just to show you how your topics are, your tokens are created. So this is all the keywords, right? These are all the tokens that we have. Year on year, we can try and do this. So from year 2014, these are all the topics that we have. If you keep scrolling down, you get next year, 2015. Further, you can keep scrolling down. We get all the years data pre-processed. So from 2014 to 2020. So we have captured all the tokens. Now we are creating another dictionary from the data that we have captured. This is for a specific year we are doing, 2023. Just to give you the information, you can see that the length of this entire dictionary is 1465. So we have the total size as 1465, and here these are some of the keywords that we are representing. Sequence and the word. This is for demonstration. We are going to try and create this kind of a key value pair for all the years. Next, we are trying to put certain constraints here to ensure that we capture only most relevant keywords. So if you observe here, we are selecting the words which occur more frequently than 10 times. The count is 10. So that means if a word is repeated at least 10 times, you consider that. And how many words we are selecting? 100,000 words we are limiting to. If you want to ensure that more frequently used words are captured, then you change it to 20 or 30, whatever your business requirement is all about. So here in independent speech, we are taking 10 words as the frequency. Now, if I keep accessing all the words which are repeated at least 10 times, there might be certain words which are not that relevant also. It could be very, very popular words. For example, Mr. Narendra Modi uses brothers and sisters as a very, very commonly used words. Now, these words I do not want. I want more relevant words which are more meaningful in extracting the true information from these speeches. So what we did is we said the words that we are selecting should be less frequent than 50% of the document. That means the words should be repeated only in 50% of the documents, not in all the documents. If you get the word coming in all the documents, that means this is basically a token or a word which is frequently used as a general term. We don't want. This concept will try and help us to get reasonable number of tokens and very useful terms, not very, very generic terms. So we are putting this constraint here, and then we are filtering the words. We're creating bag of words, and then you can see the number of topics that we are trying to capture. We've defined 3 topics, and this basically is passed as the input for the LDM1. Number of topics is 3. This would ensure that the entire document is tokenized and we get topics. Topic 0, topic 1, topic 2. And each word's frequency is also given. So we are going to now analyze all the topics. Right? Number of documents analyzed is 126. And here we are trying to create a table to capture all those details like this. So the ID, main topic, we have selected 3 topics. Topic 0, topic 1, topic 2. ID basically talks about your token ID. And then what is the contribution of that frequency? So this is basically the information that we are capturing. Then finally, we want to visually see all these words. So we will do PyLDA viz from this package. We are calling GenSib subpackage or submodule. And we are trying to generate interactive visualizations here on the Jupyter notebooks. So we are enabling the notebook first to ensure that it allows us to generate the visualization. We'll wait for it, and there you go. So this is the output, which allows us to interpret the topics very, very effectively. You can see the topics are given here, topic 1, topic 2, topic 3, right, in a scatter diagram, and the frequency of each term is given. Top 30 most salient terms is given here. Now, if I choose any specific topic, right, you can say 1. This is 0 means all the topics together. If I say next topic, it chooses topic 1. I can also click here. That will automatically change topic. I'm clicking on topic 1, and you can see these are the most relevant terms for topic 1, which is 46.2% of the tokens are there. The red color is speaking about the word's frequency in that specific topic 1, compared to the blue color, which basically talks about the overall terms frequency. So you can say this is more like a proportion that you get for that particular term in topic 1. So you see country, world, India, today, new government, right? So these are different terms that you can see. If you observe development, when I hover my mouse on the term, you can see the circle of the topics in the scatter diagram varies in sizes. 1 becomes a little small, 3 is not even existing. That means the word is not existing in that particular topic, and development is occurring majority of the times in topic 2. So you can see this kind of explanation for each topic and each term. This is with respect to the second topic. Now the difference between these two, the placement of topic 1 and topic 2, in fact you can see some overlapping is also there, is basically telling us that topic 1 and topic 2 are very similar with respect to the tokens that these topic contains. Whereas if I talk about topic 3, the number of terms that we are seeing, right, the words completely vary, right? You can see a lot of words which are not very, very relevant for this particular topic, right? So this way, we will be able to compare the similarity between the topics. Hope you enjoyed the session. I would encourage you people to analyze the results and try and come up with your comments on what was the government's agenda, how the government policies has varied over the years. I also want you to analyze on how the vision of the government changed, especially post-COVID. Try and experiment, friends. You will find very interesting points. Good luck. Thank you, friends.